Well, greetings everybody. I'd like to take a chance to show you another problem that I think you'll find on your assignment on MyMathLab. It's a little bit of a contrived problem, but we'll solve it the way that it is, and I think it gives us a chance to learn some of the techniques that we need to learn when we learn algebra. The situation goes like this. It says we have this picture frame, and I see this part. I redrew the picture because I think it needed a little more detail, but I've kind of shaded the frame structure right here, and in the middle is where the picture goes. Okay, and the unknown about it is the width of the frame. Okay, so that's what this x is up here. Like it's xy there, it's x in width there. The frame itself is a width of x centimeters all the way around. Okay. All right, so we have that. I know that the overall frame is 30 this way and 16 this way. All right. And last thing I know is that the frame itself on the inside where the picture is shown, the part that you can see the picture, is 176 square centimeters. Okay. And the question with all that information is how wide is the frame, meaning what is the x, the unknown width of the frame structure all the way around. Okay, now here's how I begin to put the information together. I thought that it might be that the overall width of the frame, like on the outside, like this, from here to here, that might be 30. Okay, that's what it says up there. And then this dimension of it might be 16. So if I go like from top to bottom, it's 16 centimeters. And if I go from left to right, it's 30 centimeters. That might be the case. But I have information about the size of the interior where you see the picture. So look what I did. I wanted to express the size of that. Do you see why I put this as 30 minus 2x? Why am I saying from here to here on the inside where you see the picture is 30 minus 2x? It's because you have to subtract the width of the frame. It might be 30 all the way from left to right, but you've got to subtract this. How big is that? That's x. Okay? And you got to subtract this too. How big is that? It's x. So you got to take 30 and take one x away and take another x away to get this length. That's 30 minus 2x. And 16 minus 2x is found in the same way. It might be 16 from top to bottom, but I've got to subtract this from it. That's x. And I got to subtract this from it. That's also x. So this dimension, top to bottom on the inside, is 16 minus 2x. Now, that allows me to express an equation. And normally when we solve mathematical problems, or often when we try to solve problems, we try to take the information that we have and put it in an equation, because odds are if we get that equation, we can find some way to solve it. So here's how I put it together. I know the area of the interior of the frame where the picture is 176 centimeters. And that is what kind of shape? It's a rectangle. And the area of that rectangular portion you see there where the picture is the length times the width. That's 176. I figured that those numbers are 30 minus 2x for the length and 16 minus 2x for the width. Okay? And whether you call this the length and that the width or vice versa is unimportant in this problem. You just multiply them together. From there, I can get something called a quadratic equation. All right? What I do is I multiply this out with FOIL multiplication. 30 times 16, 480. 30 times 2, 60. 2 times 16, 32. 2 times 2, 4x squared. And then I collect all my terms together on the left-hand side and get 0 on the right-hand side. That will be a quadratic equation. I get 4x squared. 60 and 32, that's 92x. And if I take 480, subtract that 176, that's 304. Now, I posted another video along with this one about the quadratic formula. If you already know how to use the quadratic formula, then you wouldn't need to look at that video. But if you're unsure what I mean by a quadratic equation and the quadratic formula that's used to solve it, you can look back at that video for some basic information and some examples. So here is the quadratic formula, which gives you the answers to any quadratic equation. You first identify numbers a, b, and c. The formula, negative b plus or minus root b squared minus 4ac over 2a. So there's a, b, and c. I put those numbers into that formula. I calculate the number in the root. I take the root of that number. Root of 3600 is 60. And then from there, notice how the quadratic formula says plus or minus. That implies two answers, plus and minus. You do them separately. So when I work all this all the way down to 92 plus or minus 60 over 8, what I mean is that one answer seems to be 92 plus 60 over 8, and the other seems to be 92 minus 60 over 8. Calculating each of those, I get 19 centimeters and 4 centimeters. Okay? So that solves for x being what? The width of the frame. Okay, and that's what the question was asking us. If you know the area on the inside, can you calculate how wide the frame itself is? But are these both correct? Could one possibility be 19 and the other be 4? First thing is, I think 19 centimeters is pretty wide for a picture frame, but who knows? Maybe it's a oddly shaped or large frame. Who knows? But I noticed that 19 is not a possibility, because suppose that one answer we get is 4 centimeters and the other answer that we get is 19 centimeters. And I got both of those totally fair. I did all the math correctly. But I know the width can't be 19, because say that this is 16 and I subtract 19 twice, what would you get? So 16 minus 19, that's already negative 3. If the frame's width were 19 centimeters, then subtracting the width on either side to get this dimension on the inside of the frame would give me a negative number. And that wouldn't work. That wouldn't be possible. You know, maybe this is an answer to that equation. It is. If you plug this number into that equation, it will work. But that doesn't mean it's realistic in this geometric situation. Okay? So it's just too big. If you tried to measure this frame out and make this 30 and this 16 and this 19, it would like collapse in on itself. And the frame would be so wide that there would be no picture on the inside of it. Okay, now 4 is possible. You can take 16 minus 8. Yeah, okay, that would make this 8. And you can take 30 minus 8, and that would make this 22, and so on. And that's entirely possible. All right, so that's why our answer is 4. It looks like we get 2. All right, it looks like we get 2 answers. I got what seems like reasonable numbers until I look at the actual shape of the frame and I see that 1 is just impossible. It won't work. Okay, so that's how I would solve this one. If that's good enough for you, then great. Otherwise, I can't recommend enough going back and looking at that quadratic formula video just to see something a little bit slower pace that applies to the solution part of what I just showed you.